How are we doing today? It's Mr. Novak, and today we're going to be learning about types of energy, and as you're taking notes. So already we've kind of gone over the basic types of energy in terms of kinetic and potential. We're going to kind of just quickly overview that, and we're going to get into more specific types of energy as well. So just a quick overview. Kinetic energy is the energy that an object has due to motion, so anything that's moving has kinetic energy. And potential energy that an object has due to its condition or position. So it's stored energy. So there are three types of potential energy. Our first one that we've kind of already gone over, the first two that we have here are ones that we've kind of talked about already. First one is gravitational potential energy. So sometimes we've calculated it as GPE as well. Is energy stored in an object because of where it is placed. It is found in objects some height off the ground. So if we take a look here, we have a boulder or a rock that's on the edge of a cliff, and we were doing some math problems kind of calculating that. So we had to know what the mass of the boulder was. We had to know what the gravity was, which was 9.8 meters per second, and also the height. So whatever those three things that we know, then we can calculate the gravitational potential energy. Another one was elastic potential energy, and that's energy that's stored within a distorted elastic object. So it can be found in rubber bands as well as springs. So we can see in this example right here, the springs are compressed, and if you push the springs down, okay, that will create potential energy. As well as if I stretch out the springs and pull them apart, they will have potential energy that can kind of bounce back after after I release them. And our last one here, which is more, this is the one that we haven't really gone over yet, was chemical potential energy. And that's energy that is stored in the bonds between atoms and molecules. And that's found in plants, as well as food, coal, propane, and oil. So really the biggest thing is chemical energy is things that are stored, and they have energy that can be used. So if we take a look at plants in photosynthesis when they make food, that's all chemical energy. Food, when we eat food and it goes down into our bodies and it's broken down, that's chemical potential energy that can be used for us in terms of when it's transferred into our bodies, and we can use it for other means. But that's chemical energy, as well as coal, propane, and oil. So anything like this, if we take a look, this is a gas tank here, and that's all chemical potential energy that's used, and can be used to help cars and all those things move and give energy for your house. All those things kind of all serve the same purpose. Let's take a look here. So we have a couple more examples here. So these are new examples. So thermal energy or heat energy is the total energy of the moving particles within an object. So it can be found in fire, a hot cup of tea, and an oven. So if you look here, I have this example of a flame. It deals with anything that's moving within the object, and that's the total amount of energy is heat or thermal energy. So a cup of tea, oven. Another example was when we did our skateboard. Our skateboard example was when we were looking at it when we had kinetic and potential. When there was friction involved, the thermal energy started to go way up, or the heat energy started to go way up. And that's another thing that can be used. So sometimes it's given off in the product of something. Okay. The next one, electrical energy, deals with the movement of positive or negative charges, and it can be found in household electricity and lightning as well. So we have our example of a plug. So anything that deals with electricity deals with electrical energy. So TVs, cell phone chargers, lights, any of those things when they're plugged in have electrical energy. And our next one, mechanical energy, is the movement of objects and substances from one place to another. It can be found in many things, including machines, muscles, like in your body, flowing water, ocean waves, wind, sound, and anything that moves. So mechanical energy contains both potential and kinetic energy, and it really is dealing with stuff that has machines. So our example is a bicycle, and a bicycle deals with movement, and it is a machine in terms of with gears and wheels and things like that. So anything that has to deal with like a machine or anything like that and deals with movement is mechanical energy. Okay, our next two examples. Sound energy. So is the movement of energy through substances in longitudinal waves. It can be found in music, your voice, a drum, and anything that vibrates. So we're going to learn more about waves in the next week or two. But the basic thing you need to know about sound energy is it's anything that you can hear, right? Music, your voice, drum, anything that vibrates lets off or gives off sound energy. And our next one, light energy, is a form of energy that travels in waves, and it can be seen with the human eye. So it can be found in lamps, lighthouses, and fireflies. So our example of a lamp here, it's pretty straightforward. It's a light. You can see it with your eyes, and that's one type of energy. So anything that has a light will have energy, light energy. Two more examples. So we have chemical energy and nuclear energy. So chemical energy is a form of energy stored in matter that can be released by a chemical change. It can be found in gasoline, batteries, photosynthesis, and when you strike a match. So chemical energy is dealing with anything with a chemical change, and that's something that we're going to learn about later on when we deal with chemistry. But kind of the biggest example that you'll see is with batteries. So batteries that you can see, cell phone batteries as well. That deals with chemical energy. So it's all potential energy that we have and can be used, and those are all examples. Striking a match would be chemical energy because there's a chemical change that exists when you strike the match. And our other example is nuclear energy. So it's energy that is stored in the nucleus of an atom, and it can be found in the sun and in a nuclear power plant. So kind of the biggest one to make sure you understand is dealing with the sun. So nuclear energy in the sun, that's kind of where the energy comes from. So it goes through a process called nuclear fusion. So really the biggest thing you need to know is nuclear energy comes from the sun, and then it is transferred from there. Just a quick little overview. Since we already went through all the different energy types, now I just kind of want to review the law of conservation of energy. So this is something that we learned when we're looking at our kinetic and potential energy with our skateboard, as well as the thermal or heat energy that dealt with the friction in our skateboard example. So just a refresher, energy cannot be created or destroyed. It can only be transformed from one form to another, so that the total amount of energy in the universe never changes. The only change is in the form that the energy appears in. And this is something that I wanted to kind of make sure we're understanding here, is when we're dealing with energy, it can't be created and it can't be destroyed. It only changes form, right? It transfers from one form to another form. And that's really important as we're learning about our examples from here on out. We're going to be dealing with a lot more specific types than just kinetic and potential when we were dealing with our skateboard. We're going to be dealing with more specific types of how it gets transformed. So there's two good examples here that I kind of liked to kind of make sure we understand. And our first one is for energy transformations is dealing with the television. So a TV, right? We have a TV here. It can change electrical energy into light and into sound energy. So think about it. In order for a TV to work, it needs to be plugged in. So once that TV is plugged in, it has electrical energy, and that electrical energy is then transformed or transferred into light and sound energy. So when you turn the TV on, you're watching the TV. So there's lights, there's pictures, images on the screen, and there's also sound that comes out from the screen as well. So that's a couple energy transformations that take place with a television or a TV. Our next one, a car. So a car changes chemical energy into thermal and mechanical energy. So chemical energy deals with the fuel. So we were talking about that before with gasoline, right? A car runs on gas, it needs fuel. So that changes into thermal energy in terms of it heating up the car, all those kinds of things, and mechanical energy, which is needed for the car to move. So in order for the car to move, the wheels turn, right? The steering wheel turns, the wheels turn, the car stops and starts. all those are dealing with mechanical energy. So those are two things that are a result from energy transformations within a car. And our last one is dealing with a flashlight, something that I'm sure we all have used before. So the first thing it goes we talk about is chemical energies from the batteries transform into electrical energy and then to power the flashlight. So again, dealing with transformations in a flashlight, the first thing we take a look at is chemical energy that comes from the battery. So in order for a flashlight to work, it needs energy coming from somewhere. So it starts with the battery. So the energy transforms from the battery, which is chemical energy, into electrical energy. So there's like circuits and things like that when you turn the light on and off of the flashlight. So it's turned into electrical energy. So that powers the flashlight. So it gets transferred from electrical energy to power the flashlight. And the last part is where the energy goes from light and thermal energy. So when I turn the light on, when I flick that switch, it goes from electrical to light energy and also releases heat as well. So that's really all you need to know for the different types of energy, and that's really it. So once again, this is Mr. Novak signing off. Have a great day.